Now at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they called that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Kerguelen. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Kerguelen's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Kerguelen were pushed upward, grabbing the younger rocks on land. Because of this, Kerguelen broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So, how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some Craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called Cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American Craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient Cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that Cratons might not be as indestructible as they thought. Some Cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like Cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has 3 main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the 2 blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes. but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They've found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists look closely at their chemical makeup, they realize the age of crystals matched the rocks found in Greenland, not Scandinavia. They use special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other. Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rockets spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation. But sometimes, our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet, and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 25 miles per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time as long as centuries and millennia when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The Sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole, and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth, since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth. And some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere. And these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years, and the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see any giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion, about 539 million years ago, might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's geomagnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current's negative charge, called electrons, move through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which otherwise would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever.
Well, we've been miscalling Uranus all this time. Actually, astronomers say we should be pronouncing it like Uranus, not Uranus. I can't say a different stress changes much, though. However, things could have been different. Initially, Uranus was supposed to have the majestic king-like name of George, because astronomers wanted to name it after King George III. In the end, they changed their minds, and now, well, it's the punchline of every joke. If you take the total cost of launching a mission and divide it by the weight of the cargo, you'll see some pretty mind-blowing figures. According to specialists, back in 2016, it used to cost $10,000 to send just 1 pound of cargo into space. But now, prices have gone through the roof. Cygnus spacecraft's cargo costs over $43,000 per pound, while SpaceX's new carriers come in at around $27,000 per pound. Remember how hard it is to pay $5 for water at airports? Now, a bottle of water in space would cost somewhere between $9,000 and $43,000, and that's only to have it delivered in space. Now, as for water in space, well, it used to be considered a super rare thing. But in reality, there's water ice all over our solar system, so you don't have to buy those overpriced $43K water bottles. It's hanging out there in comets, asteroids, and even in hard-to-see craters on Mercury and the Moon. We're not sure if there's enough water in these places to support colonies of people, though. Mars also has ice at its poles, hiding under the surface dust and frost. Even smaller celestial bodies, like Saturn's moon Enceladus and dwarf planet Ceres, have ice. NASA scientists think there might be a chance of finding life on Jupiter's moon Europa. There might be liquid water beneath its icy shell. Europa, even though it's a lot smaller than Earth, might have an ocean deep enough to hold twice as much water as all the oceans on our planet combined. In 2009, scientists exploring a massive cloud of dust and gas in the center of our galaxy stumbled upon a fascinating surprise. They found ethyl formate within the cloud. This chemical is responsible for the delightful flavor of raspberries and has a rum-like scent. Furthermore, another nearby region is brimming with ethyl alcohol, the same type found in many beverages. In fact, there is enough alcohol in this region to provide every person on Earth with 300,000 pints of beer every day for the next billion years. Now, believe it or not, we do have a black hole on Earth. The thing is, creating an in-lab black hole was a sort of indispensable thing to do. Studying black holes in real space remains a distant dream, so it was only possible to create one to experiment with in a lab. A group of scientists in the Netherlands wanted to explore the mysterious Hawking radiation theory proposed by the iconic Stephen Hawking. Using atoms to mimic an event horizon, they orchestrated electrons, causing a surge in temperature that resembled flat spacetime. As particles moved through quantum fluctuations, a ring of infrared radiation appeared around the lab-grown black hole, mirroring Hawking's idea. So, if you totally understood what I just said, could you please explain it to me? Now, it may sound insane, but you can totally be allergic to the moon. Long story short, it was the final Apollo mission, and they brought back more rock samples than ever before. Plus, they had the first and only pro-scientist on the moon, Jack Schmitt. He was a geologist, and his rock samples helped scientists learn more about the moon's magnetic field and volcanic history. During the expeditions, it became evident that Jack Schmitt was allergic to moon dust. The gritty, sticky powder clung to his suit and his skin, causing irritation in his sinuses, nose, eyes, and throat for a couple of hours after he took his helmet off. Meanwhile, neutron stars are extremely dense, being basically just a bunch of neutrons squished into a super small space. If you had just a teaspoonful of this stuff, it would weigh more than the entire human population combined. And to match the density of a neutron star, we'd all have to squeeze into the space the size of a sugar cube. No thanks. When it comes to outer space, we tend to think that Earth and the Moon are pretty close together. But in reality, you can actually squeeze all the other planets of our solar system between Earth and the Moon. The average distance between them is about 240,000 miles. If you added up the diameters of the 7 planets, you'd still have some room to spare, about 5,000 miles. In 2011, scientists made a groundbreaking discovery of a massive reservoir of water in space. This water, equivalent to 140 trillion times all the water in Earth's oceans, could provide each person on our planet with a planet's worth of water 20,000 times over. This reservoir was located near a massive black hole drawing in matter and emitting energy, known as a quasar. The water was formed by energy waves colliding hydrogen and oxygen atoms together, and it was found around 12 billion light-years away. So, when the Curiosity Mars rover snapped its very first sunset picture in 2015, scientists were practically doing backflips from excitement. Turns out, sunsets on the red planet are anything but red. They're actually a stunning shade of blue. According to NASA, the reason behind this phenomenon is that the dust in Mars' atmosphere is like a magical filter that lets blue light shine through while blocking out those warm tones like yellow, orange, and red. Well, Venus is a slow spinner compared to Earth. It takes this planet 243 days to make a full rotation, and it spins in the opposite direction. But even though Venus takes longer to spin around, it zooms around the Sun in just 225 days because it's located so close. So, believe it or not, a year on Venus is actually shorter than its day. So, you might think that the night sky should be full of stars with no dark spaces at all. This idea is known as Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers. He thought that if the universe was infinite, unchanging, and timeless, then we should see stars everywhere we look. But it turns out that the universe is not infinite, unchanging, or timeless. Edwin Hubble discovered that the universe is actually expanding, and the leftover radiation from the Big Bang tells us that the universe is about 13.8 billion years old. Think of all the birthday candles. Ooh! So, the reason we don't see stars in every direction is because some stars are just too far away, or they haven't been around long enough for their light to travel all the way to us. During the Apollo 16 lunar mission, Ken Mattingly, the command module pilot, had a bit of a scare when he realized his wedding ring was missing. The whole crew frantically searched the spacecraft for it, but no luck. Finally, on day 9, while Mattingly was on a spacewalk, the ring was spotted floating out the hatch door. Charles Duke Jr. tried to grab it but missed. Luckily, it bounced off Mattingly's helmet into Duke's hands. It's cool they found the ring, but there are many other things people left up there. There's even a toothbrush floating around somewhere. Mercury is already the tiniest planet in our solar system, not counting Pluto, of course, and the second densest after Earth. And believe it or not, it's actually shrinking and getting denser. For a long time, scientists thought Earth was the only planet with tectonic activity. But that all changed when the Messenger spacecraft flew by Mercury, giving us a detailed scan of the whole planet. In 2016, Messenger discovered these cool cliff-like formations called fault scarps. Since they're still relatively small, scientists think they're pretty new, suggesting that Mercury is still contracting 4.5 billion years after the solar system began. And around 10 years ago, Australian astronaut Luca Parmitano went through a near-drowning experience during his spacewalk due to a water leak that went unaddressed. Nobody knew how it happened and why Luca ended up having water in his helmet. NASA was investigating the issue for months, but they were unable to determine the exact cause of the water entering Luca's helmet.